And here is a beautiful question, and it's a challenge to you. Those who will get the answer, please put your answer in the comment section. Let's see how many of you can take this beautiful challenge of J advanced types. Let S minus be semicircular arc defined by the first equation, and S plus is the semicircular arc defined by the second equation. R be the locus of all points P such that P is the intersection of two lines, one of the form Ax plus By equals 1, where AB belongs to S minus, and other of the form Cx plus dy equals 1, where CD belongs to S plus. What is the area of region R? Express your answer as a fraction in simplest form. So I hope all of you have understood the question. So if I define what is set S minus, so all those point xy, we satisfy this condition. So you can clearly see it's a circular arc whose center is minus 1 comma 3 by 2. So it's minus 1 comma let's say 3 by 2 over here, and its radius is half, right? So its distance is 3 by 2 and its radius is half for x less than equal to minus 1. So how this arc will look like? Clearly this will be the entire circle, right? But with radius x less than equal to minus 1 constraint, we'll keep only this part of the curve, right? We'll have only this part of the curve as the arc. Similarly, what about the second part? Its center is 1 comma 3 by 2. So it's at 1 comma 3 by 2 with again the radius as half. So we'll have this curve is exactly its reflection, something like, right? Now what does the problem means? So I'll just try to explain to you the problem. So we have one arc over here, other arc over here, right? And we are calling it S minus, and this is called S plus. Now of course this set S minus will have infinitely many points. We'll have A, P1, P2, P3, P4, P5, P6 till P infinity. I'm just giving some special points here, and you can see so many points are over this region, right? R be the locus of point P such that P is the intersection of two lines, one of the form Ax plus B, where AB belongs to S minus. Now that's very interesting. If I see this point, let's say A and B is selected such that A comma B represents the ordered pair of this point, right? Similarly, we'll have this point, it's also from this set S minus from this point. So with all these points having x and y coordinate as A and B, we are making family of lines, and that's really cool because those values A and B, that is taken from this set S minus. So that will satisfy this expression, right? For example, one of the value will be, let's say, x equals minus 1, and that will give you y value as 3 by 2 plus half. So half plus 3, which gives A and B ordered pair as A equals minus 1 and B equals, so corresponding to this strip value if I take, it's 2. Right, with A minus 1 and B 2, I can draw a line which is minus x plus 2y equals 1. So x0 y half, y0 x negative 1. So we have this line over here, right? Similarly, I can take this point and we can make a line. For example, x value is, let's say, 1 and y values, that height becomes again 2. So with 1 and 2, I can make a line cx plus dy, which is x plus 2y equals 1. You can see x0 y1, y0 x1. So we'll have this line of intersection, right? So with this point 1 comma 2, if I make a line, it will be seen something like this. Similarly, you can take this point, lower point, so it will have 1 comma, and now you can see this entire height is 3 over 2 and take away 1. So that will be 1 comma 1, right? So with 1 comma 1, the equation of line that I'll get is x plus y equals 1, right? So if we keep on doing, you see this is the point of intersection. The point of intersection will form a region. You need to find the area of the region that we are getting. So it's really interesting question, and I'll solve this problem in the upcoming lectures. This I have also incorporated in my upcoming book which I was talking about. Thank you. Have a good day.